Alright, so today we're going to learn how to draw Lewis dot structures, or Lewis dot grams, I don't know, whatever you want to call them, diagrams, whatever. Step one is to find the least electronegative atom. So if we're drawing a Lewis dot structure diagram for CO2, you gotta find the least electronegative atom. So in this case, you pull out your handy dandy electronegativity chart, as mentioned here, or just look up the electronegativity of a certain atom, whatever you want to do, whatever you have the resources for. Electronegativity chart. You see that carbon has a lower electronegativity, so you have carbon here and an oxygen on the other side. Step two is to draw the thing out with bonds. So you draw it out with bonds. So you have an oxygen bonded to a carbon that's also bonded to an oxygen. They're all bonded all the way across. Now for step three, you count up the valence electrons. What you do is you pull up your handy dandy periodic table. You see that oxygen has 6. So we have 2 oxygens, oxygen and oxygen. So that would be 12 total valence electrons plus the carbon, which has 4. So 12 plus 4 would be 16. So step 3 is count up valence electrons. The E minus means electrons. And you find out that, like we said, there are 16. For the next step, you draw the electrons on electrons, that's what that means. So it's oxygen, carbon, oxygen. To draw on the electrons, you need to give each atom or molecule a full octet, so a full 8 electrons, because that's the reason they bonded together, to get the full 8 electrons, except for hydrogen and helium, which require less amounts, but that's a different story. Actually helium can't bond, so just hydrogen. Hydrogen only needs 1. Everyone else needs 8 total valence electrons. So for the oxygen, you've already got 2 because it's shared with the carbon. So there's already 2 on the oxygen. So you only need 6 more to make that full 8. So you draw on the 6 electrons around the atom away from the bond in pairs of 2. And then carbon has 2 from oxygen and 2 from the other oxygen. So then it only needs 4 more. You draw 1 here, 2 here, and 2 here. So there's a full 8 because you got 1, 2, 3, 4, 5, 6, 7, 8, because these are worth 2, remember? So now you draw the 6 on the other oxygen because oxygen is just bonded here. So it's already got 2, and then you need 6 more just like the other oxygen. Step 5, count them up. Count up how many valence electrons are in this, and remember you can only hold 16. So if you get a set amount of 16, you're done, and that would be your Lewis dot structure right there. But sometimes it doesn't always work like that, so you got to count them up. So you count them up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then don't forget the bonds. These each count as 2. So 17, 18, 19, 20. We have 20 valence electrons, but we can only have 16 here. So what you have to do is the next step. Double or triple bond it. So to double bond it, you redraw it, oxygen, bonded to carbon, bonded to oxygen, and each bond here is worth 2, but really it's taking 2 from here and 2 from here. So it's really got a full value of 4, but you only count it as 2, because really there's just 2 shared electrons there. So there's 2 here, that each, so they can each have their 8, but really it's just 2 electrons being shared between them. You could actually just draw it like this here, the 2 orange dots. That's showing that these each are sharing those 2 electrons. So if it's got 2 electrons, but it's giving off 4 total, it's counting up for a total of 4, that means it's taking off 2 every time you bond. So if we add another bond, and then add up all the electrons on again, we've only got 18 now. And to get to 16, we can add another double bond here to this oxygen, or you can triple bond here. To keep it simple, we're just going to double bond here. So now you have a double bond, and this carbon already has its full 8, because it's got 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons just from shared, and then this oxygen still needs 8. It's only got 4, so you draw 1, 2, 3, 4 more on, and here are the other 4. Same thing with the other oxygen, 1, 2, 3, 4. Now you count them up again for your final step. You got 1, 2, 3, 4, 5, 6, 7, 8. Remember these count as 2. 9, 10, 11, 12, 13, 14, 15. We got 16, baby. So that means that this diagram matches the exact diagram for what CO2 would look like. It's got the right number of electrons and the right number of bonds. And so that's how you do it. Like I said before, if you just end up having the good number, like when you draw out some other ones, like I know H2O doesn't have to double bond or anything like that. You're just done at this step. You don't even need 5, 6, or 7. But sometimes you run into some special cases of polyatomic ions which have charges on them. So say we were drawing up the Lewis dot structure for, let's say, phosphate. That marker does not work. Try it again. Let's say phosphate, which is phosphorus and oxygen bonded together. And there are 4 oxygens, and it has a total charge of -3, which means there are 3 extra electrons on this because it's got a negative charge of 3. So rather than there being the same number of electrons as there are neutrons, or protons, sorry, this polyatomic ion has a 3- charge, so it's got 3 more electrons than it does protons. So to draw this one up, you start out with the first step, find the least electronegative atom. You refer to your sheet, you find out that it is phosphorus. Phosphorus goes in the middle. Oxygen, 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 oxygen. Step 2, draw it out with bonds. Draw a bond there, bond there, bond there, and bond there. Count valence electrons. Pull back out our periodic table. We find out that phosphorus has 5, so there's 5, and then oxygen has 6, so there's 6, 12, 18, 24 plus 5, 29. So now you start to draw them on. That's the next step, draw them the electrons on the structure. So this already has 2, and then 1, 2, 3, 4, 5, 6 more. This over here, same thing. It's all just the exact same bond. So all of them are going to look very similar, if not identical. So there we've got it. The phosphorus already has 2 here, 2 here, 2 here, and 2 here, which is a total of 8. So that doesn't need any electrons. It's all got shared electrons with the other oxygens. Now you count them up. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 30, 31. Wait, no, I counted that wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 30, 31, 32. We got 32. That is the correct number because 29 with 3 extras, because there's a -3 charge, each one of these little dots has a negative charge. So 29 electrons plus the 3, the extra 3, pulls us for a full 32. You don't need any double bonds. You're done with that. That would be the electron drawing for phosphate. Just kidding, there's one last step. Oxygen, phosphorus, oxygen, phosphorus, oxygen, oxygen. Draw on your electrons. This right here is just PO4. They don't know that it's PO4 -3. So what you do is you draw your diagram, your structure, whatever you want to call it. You put them in brackets, and then you put this little 3- right there, and that signifies that there are 3 extra electrons. Or if it were 3 less electrons, then it would be 3+ there. But in this case, it's 3-, and there you have it. So now you know how to draw Lewis dot structures. For the most part, they all follow the same rule. Hydrogen can never be in the middle. You gotta find the least electronegative, but hydrogen can never be the least electronegative. Draw them out with bonds, count the valence electrons, draw on the valence electrons, and then if the number matches up with the number of valence electrons, you're done there. But if not, it doesn't always, like in CO2. You count them up, you find out there's 20, that's okay. Then you're drawing on double bonds, or you could just bond it 1 here, 3 here. Either way, all works out the same. That still gets 4 bonds, and then you just put 2 here and 6 here. And that still gets 4, and that's still got 8. 8, 8, 8, 8, 8. Amen. Done.